Alright, so how do we measure arc length and sector area of circles? Just to remind us, arc length is this just arc on a circle, just trying to find that length, and then sector area is the area of part of a circle. Alright, arc length. So we can find arc length, this distance around the circle, using s equals r times theta, or or we can solve for the angle, the central angle, theta equals s over r. So that r is my radius, theta is the central angle in radians, and a little note, the direction matters. So if I go counterclockwise, it's positive. If I go clockwise, it's negative. And then S is the arc length. Alright, so in these first two examples, we're given a circle with a radius and a arc length, and we're going to solve for the angle in radians. So I'm going to use my theta equals the arc length over the radius. I can see that this theta is positive because it's going in a counterclockwise direction. So theta equals the arc length 13 over 10. That doesn't reduce, so it's just 13 over 10 radians.
Hey, it says find the length if the arc given the radius.
Okay. Alright, in the second example, we have an angle that's going in a negative direction, so this theta is going to be negative s over r. So theta equals negative 10 over 4. That reduces, so my theta is negative 5 over 2 radians. Okay, in the next two examples, we are given the radius and theta, and we have to find the arc length. So S equals r times theta. So S equals 6 times 4 pi over 3. Or we multiply and we get that the arc length is 25.13 units. In the second example, I'm told that the radius is 10 centimeters, but the theta is 120 degrees. But this formula only works if we're in radians. So that my first step is I have to convert the 120 degrees to radians. So to convert from degrees to radians, I take 120 and I multiply by pi over 180. So 120 degrees is 2 pi over 3 radians. Now I can take S equals r theta 10 times 2 pi over 3. To get that, the arc length here is 20.94 centimeters. Alright, if we're trying to find just the area of a piece of a circle, so the sector area, we can go about it two different ways, whether we're given the theta in degrees or in radians. If we're given it in degrees, then we can set up a proportion. Okay, so we can just take our theta and divide it by 360, and we can say that that equals my sector area over the entire area of the circle. So what we've done is we've taken our piece of the circle in degrees divided by all the degrees of the circle equals our piece of the circle's area over all of the area. If we're given radians, we can use a formula. The area is 1/2 of the radius squared times theta. Alright, so let's look at an example of each. Find the sector area of the circle given the central angle and the radius. So if I said, okay, we have a radius of 5 meters with a central angle of 45 degrees, find the sector area that this covers. So I'm giving it in degrees, so I'm going to set up a proportion. This area takes up 45 degrees out of the 360 degrees. So how much area does it take up out of the entire area of the circle, which is pi times 5 squared? I've got a proportion, so I'm just going to cross multiply 45 times 25 pi, and then divided by 360. Alright, so I have 3,534.29 equals 360x. So divided by 360, my area x equals 9.82 meters squared. Alright, for our last example, let's say we were given a radius of 70 feet and in radians the theta was 2 pi over 3 radians. Okay, so my central angle is 2 pi over 3 radians with a radius of 7 feet. I'm going to plug that into the area equals 1/2 of my radius squared times theta. So 2 pi over 3. So I just square 70, take half of it, multiply by 2 pi over 3, and I get an area of 5,131.27 feet squared. So we can use either method to solve for the sector area of a circle. And if you just like one of the methods, you can just convert from radians to degrees or from degrees to radians and solve with either equation.